Hello everyone, I'm Hui, and today I'm going to discuss the topic of wind turbine. As we all know, wind turbine generate electric power by wind source, but how it transforms from wind to electric power is actually go through few steps. So let's start with a short brief with the internal structure first. So wind turbine basically is formed by rotor with blades. So the lift forces on blade generate by wind to push the blade and make the rotor to rotate. And the rotor was linked to a gearbox with a shaft, so the gear will turn simultaneously with the rotor. And after that, there's a small gear attached together with the big gear to create a different gear ratio to drive the generator in high speed and produce electricity. And you can see this picture. There's an other component inside like uh, anemometer and wind vane is to detect the wind direction and wind velocity. It send a signal to your motor to control the direction of nacelle, which is always facing the wind flow. And coming to the sensors using in wind turbine, although the machine inside nacelle it looks simple, but the way it use a lot of sensor as well, like temperature sensor to prevent component overheating, level sensor and pressure sensor using on hydraulic cooling system, and anemometer and wind vane is to detect the velocity and wind direction. And eddy current sensors is used to detect change in electric current create when a conductive material enter a moving magnetic field, and as well as the displacement sensor to detect very small movement of the foundation in relation to the tower it caused by repeat crashing by wind or wave or caused by resulting structural defect. So today we will focus on direction of wind turbine, meaning of the movement of nacelle is controlled by the wind vane. This is how it look. It can be independent standalone unit, or you can see in picture it attached together with the wind turbine. So the working principle of nacelle rotation is basically explained by the input as we know as the wind. When the wind contact which the major element is sent signal output to the controller to call your machine to work. Meanwhile, on the same time, there's a yaw counting sensor to detect the current position and make sure the result of direction was matched with the desired output direction. And you can see this is the wind vane product potential meter wind vane W200P. And we can see that the repeatability of this product is plus minus 0.5 degree with the accuracy of plus minus 3 degree in steady wind over 5 meter per second, and recommend power input was 0.5 watt. And this is a graph of output percentage of voltage versus the wind direction. Since the default direction is always facing north, if the wind blow at the direction from north, then the output voltage are very minimal. But if the wind is blow from 350 to maybe 357 degrees away from north, meaning very close to north, what it will do is the output voltage will reach almost 100% to call the nacelle to rotate facing wind direction. Why not just 5 to 10% of output voltage? Because uh, it only allowed to move in one direction, meaning either clockwise or anti-clockwise. So if the wind direction is from 350 degree or something, or although it's just 10 degrees away from the north, but it will still reach high output voltage to call it rotate to a big displacement. And for the next part, I will pass to my team member, Puteri no Adilah. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hey everyone. So today I will continue for actuator part, and the actuator chosen is your actuator in the wind turbine. So basically the diagram shown is your drive mechanism. It consists of electric motor, gear, shaft pinion, ring gear, yaw bearing, back plate, tower flange, brake ring and yaw brake. So basically the picture is the yaw drive mechanism, and the most important part is one of it is yaw bearing. Number one, yaw bearing. So yaw bearing is basically the most crucial part and cost intensive component of a yaw system. It is found on modern horizontal axis wind turbines, and it can cope with enormous static and dynamic loads and moment during operation. So it is basically to provide smooth rotation of nacelle under all weather conditions, be it windy, basically in windy conditions lah, because it is to capture wind energy, right? So the next one is it is corrosion and wear resistant and extremely long lasting, because it should last for the service life of the wind turbine while being cost effective. So the next one is the electric motor. So the electric motor on basically the electric motor on big turbines use small electric motors or hydraulic ram to swivel the blade back and forth under precise electronic control. So on smaller turbines, on the other hand, the pitch control often completely mechanical, so it passes directly into oncoming wind and captures the maximum amount of energy. So the third part is gear. So basically the gear convert the relatively slow rotation of spinning blade into higher speed motion, making the drive shaft quickly powering electricity generator. So the next one is number 4, which is brake. So brake basically function to stop the rotor from turning. Basically this is for safety reason and for routine maintenance. So number 5 is gear rim and pinion. So basically it is big in diameter, normally larger than 2 meters, and orientation of its teeth. So the gear rim speed teeth on outer surface have higher reduction ratios with the pinions. The machining cost over the gear rims with inner teeth also reduce. So the next one is your drive. As we can see in the picture, is the example of your drive with electric motor, internal brake, magnetic or spring-loaded type. So the gearbox with planetary stage with mounting flange, the shaft and pinion measures with the gear rim. So what your drive's function? Basically it is to rotate the nacelle on upwind turbines to keep them facing the wind when wind direction changes. So your motors power the yaw drive to make this happen. So basically the gear rim and the pinion of the yaw drives are the component that finally transmit the turning moment from the yaw drive to the tower in order to turn the nacelle of the wind turbine around the tower axis, z-axis. The last one is the last slide is about gearbox. Basically the gearbox converts the low speed rotation of the drive shaft around 16 revolution per minute into high speed around 1600 revolution per minute, for example. So it is actually fast enough to drive generator efficiently. So the next one is generator, which is located behind gearbox, and it takes kinetic energy from spinning drive shaft and turns it into electrical energy. And basically running at maximum capacity, typically 2 megawatts, turbine generator will produce 2 million watts of power at about 700 volts. Yes, and I think that's all from me. Thank you so much. Bye bye.